Heidi. Back to our notepad on page 16, we skipped a few examples of complete reactions, and I'm okay with that. I want to practice half reactions first and introduce a basic solution. Remember what we were just practicing were half reactions in acid? Sometimes redox occur in a basic solution. I remember acids always start with hydrogen ion. That's why we balanced with an H plus in the previous examples. In a basic solution, it's the hydroxide ion that we use to balance the equation. Here's the important thing. Steps 1 through 8 that we have practiced are all identical. There's 2 more steps when we're balancing with a basic solution. Let's read out loud. Oh, yes, we can. Rule number 9. Reading out loud. Ready, set, go! Now one more time, rule number 10, but this time maybe with some energy. Ready, set, go!
Add enough OH to both sides to neutralize the H+.
We got off in our choral. Yeah, that's a negative side. Add enough hydroxide to both sides to neutralize the hydrogens. Here's what we just said. Back to your sheet of paper. I would like to practice a half reaction before we put them back together for complete reactions. So it's the same problem we were just working. It is one of your homeworks, but now, whoops, I want to go this way. Let's tack on the next letter. It's called D. Same problem, half reaction, but now we're going to do this in a base solution. If hydroxide OH negative forms oxygen in a basic solution, what would the half reaction look like? Well, it's the same series of steps. It says step 1, balance, or it's already broken into a half reaction. There are no elements other than H's and O's, so I start by balancing the oxygens with water. There's 2 O's on the right, 1 on the left. I'm going to add a water to balance the oxygens first. Next rule says we got to balance the hydrogens with H positives. Those are called protons. There's 1, 2, 3, 4, 5 hydrogens I'm counting on the left-hand side. 2 times 2 is 4, plus 1 more from the original gives 5. I have to add 5 hydrogen ions. Rule number 6, balance electrically, thinking about electrons. Over to this side, the net charge so far is a -1. Over on the right side, the net charge so far is a +5. To the more positive side, we add electrons, so they end up with the same charge overall. Thinking on a number line, these are actually 6 steps apart. I've got to add 6 electrons to both sides. Now this has become a net -1 on the product side. They're electrically balanced. If, here's the big if this were an acid solution, we'd be done. But it says it's not. It's in a basic solution, so there's an additional step. The number of positive protons have to be balanced with hydroxides. Here's what we just said. If I added 5 protons to balance the hydrogen ion, I've got to neutralize those. And I'm going to do so by adding 5 hydroxides. But what I do to one side, I've got to keep it balanced. I've got to add it to both sides to keep the equation balanced. Just as you do in math class, what you do to one side, you have to keep it balanced by adding it to the left. The additional step says we have to neutralize the acid with the base ion. 5 hydrogens and 5 hydroxides combine. 5 H's and 5 OH's really are 5 water molecules. We've neutralized. Over here, I can see a net total of 6 hydroxides. Let me rewrite what we have and see what we can do to simplify. Just rewriting, we have 2 waters and 6 hydroxides. I combined 1 with the 5 we added. The original oxygen, 5 protons and 5 hydroxides combined to make 5 waters. And we still have those 6 electrons we added to keep it electrically neutral. I still think we can simplify. I notice on the right I have 5 waters, and on the left I have 2 waters. I can simplify that further by showing a net remainder of 3 water molecules. The answer, the final real answer, 6 hydroxides form oxygen, 3 waters, and 6 electrons. The loss of an electron is an oxidation half reaction. I'm going to repeat myself. To balance this half reaction, we did exactly the same steps as the acid. We balanced the O's with water. We balanced the H's with the hydrogen ion. We balanced the charge with electrons. The additional step was adding hydroxides to balance out the hydrogen ions. In a basic solution, you better end up with OH negative. In the acid solution, we had hydrogen ions, and then from there, we just simplified. When Leo equals Ger, we combine them back together, and we get what's called a complete reaction. Let me turn the video off and just focus now on letter E. Take a moment, following the example. It's a basic solution. Work with a neighbor and see what we can find.